The battery exploded and caused a fire, killing the 42-year-old. His wife is critical and 2 daughters are being treated at a hospital in Vijayawada, Andhra Pradesh.
इलेक्ट्रिक स्कूटर्स में आग लगने की बढ़ती घटनाओं के बारे में बताएंगे। पिछले एक हफ्ते में ऐसी 4 घटनाएं हो चुकी हैं।
And now an electric vehicle battery explosion has claimed 1 life and has left 2 others injured in Hyderabad.
ఎలక్ట్రిక్ బైక్స్ ప్రాణాలు తీసేస్తున్నాయి. తాజాగా విజయవాడలో మరో ఎలక్ట్రిక్ బైక్ పేలిపోయింది. ఈ ఘటనలోనూ ఒకరు ప్రాణాలు కోల్పోయినట్టుగా తెలుస్తోంది.
Solar Electric is recalling 1,441 units of its electric two-wheelers in the wake of incidents of vehicles catching fire, according to a company statement.
How the cell performs in a lab is very different from how the battery pack will perform in the field. And that's how we make sure that if we are continuously cycling it at different C ratings. So what a lot of people are missing right now in India is the cell testing and validation stage. We use cylindrical cells and we arrange them in series and parallel. This is not just aluminum, it's an aluminum alloy mixed with a proprietary metal which allows for a high thermal conductivity. Motors IP68 rated, so it's not 67 but 68. So it's a swap station where we have a 12 slot system. It also have a cooling unit.
Hi, hello, namaskara. I'm Pradeep and hope you guys are doing great. As you can see here, I'm in the Hop Electric and this place is called Launchpad because this is where all it started. So I had a lot of questions and so Hop Electric CTO and the co-founder is there to help me out with this. So I was shooting him a lot of questions. He was helping me out. So I thought, why not share that information with you guys as well? Because in the recent times, we are having a lot of incidents where safety of the EV is questioned. So how is Hop solving all that? And let me introduce the co-founder and the CTO here. Hey brother, hi.
Hi Pradeep.
Tell us a little bit about yourself.
Yeah, sure man. So Rahil this side, I'm the co-founder CTO of Hop Electric. So this place is Launchpad. This is where the real magic happens. This is a development center, one of its kind. And we develop batteries, we develop powertrain and all the other electric vehicle components here. So the whole system design and system integration happens here, and then we take it into a production facility which is nearby, from 10 kilometers from here, and then we have the production facilities which can facilitate around 1.2 lakh units per annum. So let me show you around.
Yes, so we got the special access to the R&D which not a lot of people have. So let's go inside so that all the questions will be shown out with the practical examples. So let's go inside. All right, Rahil.
Yeah.
So thanks for having me in the R&D center. So my first question is, there's a lot of incidents that are happening around the EV in the recent times.
Correct.
And not a lot of people have definite answers why it's happening.
Correct.
And what kind of research happening behind it as well. Since we have the access today, show us a little bit about what are the safety precautions that you guys are taking.
Right.
Explain us.
Sure. So I'll start with the fundamentals. Why EV batteries catch fire, and then also what can we do to prevent these, right? So let me take you around to so there are primarily 3 reasons why EV batteries catch fire. The first one being poor cell quality, the second one being poor battery pack design, and the third one being not a good quality battery management system, so to say. You know, when you include these 3, if you got any of those things wrong, it's a recipe for disaster. And that's what's happening in the Indian EV ecosystem right now, that people either are not using good quality cells, they are using Chinese offtake B grade, C grade cells. They are not investing a lot of money into good quality and processes when it's come to battery pack design. So in the battery pack design, fundamentally, if you have a good mechanical design, a good thermal design and a good electrical design, you're sorted. But most of the time, people want to have a cheaper price point for the battery pack, and that is why they're not investing much on the processes of mechanical design safety, thermal safety, which is a huge factor behind these fires, because once you have a thermal validated pack, you are not prone to EV fires, then you are safe, right? And then electrical safety, of course, with short circuit protection, over voltage protection, all those things. And then comes the BMS part, where sensing and controlling. So there are 2 parts to the BMS. It monitors all the touch points, data points, parameters. It also, controls them when it is out of hand. So that's where the BMS comes in. It is an intelligent monitoring and controlling system which controls each and every cell, what is the health of it, what is the depth of it, each cell, and how we can manage each cell effectively with respect to mechanical thermal safeties.
My next question is, so see, at end users will not have access to the battery cells.
Sure.
See what kind of cells that is used in the battery
Sure.
pack.
Sure.
But here we have quite a few examples.
Sure.
So
Sure.
show us what cells that mostly are used and why it's important to have good quality cells.
Yeah, sure. So so there are array of cells and grades which is presently available in the market. If I have to show you, so these are 18650, these are 2170 to 21700 cells. These are 32140 cells, which we have access for the in proprietary development which we are doing in house right now. So there are two type of chemistries available. Let's start with that, right? So there are LFP and then there's NMC, right? NMC is nickel magnesium cobalt, LFP is lithium iron phosphate. So with NMC, it is prone to much for fire hazard or thermal runaway because it's an active chemistry. With the LFP, it's a more safer chemistry. It gives more cycle life, but it has its own issues like not proper balancing over a lifetime, low energy density compared to NMC and other factors. So we have a trade-off, and the chemistry of the cell and the selection of the cell has to be done by the application. Is it going into energy storage packs? Is it going into two-wheeler, four-wheeler? So from that, you start with the application, you scale down on the cell, then you create a model of a cell, how that cell would perform in the real world. And then from there, you start the battery pack design.
Correct.
So what a lot of people are missing right now in India is the cell testing and validation stage, which
So that's what's happening here, right? Cell testing.
Yeah. So what we do is for each cell that we select for the particular application, we test them between 4 to 6 months in a lab, and that is an accelerated testing which gives us results for like 2 or 3 years. Correct. So we compress that 2 or 3 years timeline into months time so that we know in an accelerated way that how the cell will perform in the field, right?
Correct.
But that is not enough because how the cell performs in a lab is very different from how the battery pack will perform in the field. So we have steps and processes to make sure when the cells are converted into packs, so cell into model, model into pack.
Correct.
The pack needs to perform on the pack, right? So we do first testing and validation on the cell level, then we do characterization and modeling for the cells.
So what's happening here in the machine?
So what is happening is right now this is called as cycling. So we are cycling it at different C ratings to make sure if the C rating of the vehicle. So when you pull out the throttle, you extract a lot of current from the battery pack, and that battery pack extracts a lot of current from each individual cell. Correct. So you need to make sure at high C levels, at high C ratings, these cells should perform. Correct. So we cycle them at high C ratings to see if there is a continuous performance expected from the battery pack. What is the health of the battery pack after certain cycles? That's what we make sure by our testing and validation. So we test those cells at a worst conditions to cycle like what will happen after 400 cycles, after 1000 cycles.
So here what's happening is they're charging and discharging at a rapid rate.
At a rapid rate.
different
It's not a standard rate which is given by the manufacturers, but we do at a rate that is expected by the customer.
Correct.
Right. So we do those testing here. We do type of a abuse testing so that we know what is the breaking point for the cell, what is the breaking point for the other different type of chemistries, and then we take it ahead for the battery pack design.
All right. So we understood a little bit about the cells now. See, cells are not the only thing. So you have
Correct.
to keep multiple cells in a battery pack.
Correct.
So you have to make a battery pack.
Sure. Before that, I'll show you how we do it. So if you can see this, coming closer. So we have data over what we have collected from the cells, right? And then we also are cycling it continuously for other different temperature levels. So we know the temperatures. We know the temperatures and what are the temperatures level going for the cells. And that's how we make sure that if we are continuously cycling it at different C ratings, what is the maximum and the minimum temperature the cell goes in.
Different cell. 34.0.
Yeah. So you know the ambient temperature for the Indian roads in the summers goes above 45 degrees, right?
45.
In certain areas. So we are in Jaipur, standing in Jaipur, Rajasthan right now at the peak of the summers, right? Yeah. So right now the temperature outside is 44 degrees. Okay. But still we have the testing and validation data where we have crossed 60 degrees temperatures on the pack level. Still the cells are able to perform at their desired C ratings.
Correct.
That's the magic we do because we take care of the thermally stable pack and we take care of how the cell will perform at those temperatures. So we already know what are the outcomes, and from there we design the software and the BMS to modulate the current and voltage parameters.
So as soon as you get the cells, so first check it
Yeah.
with the number of cycles, with the rapid charge and discharge,
Yeah.
and also to check how that cell performs with the temperature as
Yeah,
well,
yeah.
how much thermal output is happening.
Correct.
How
So
much
different
heat it produces.
different C ratings. What is the thermal output? What is the electrical output? What is the structural output? All those things. So here at the cell level, it's not much about the mechanical strength, but it's mostly about how the cell will perform in electrical and thermal conditions.
Correct. And also my next question is, see, you can't take an electric scooter and test in every city, right?
Correct.
That's not possible. So, but if you take as Indian demography, a geographical location as in India, which has coldest place up north,
Right.
to summer here in Gujarat, again
Right.
cold in northeast,
Right.
again if you go to Chennai, it's super hot.
Right.
So different climatic conditions,
Right,
but you
right.
can't have different scooters for each region, right?
Correct.
You need to have one product which can cater for everyone.
Correct.
So how do you get that product? How can you achieve that safety?
Yeah, so this is a very good question actually. So because India is a very diverse country in terms of both population and geographies,
Correct.
what we intend to do is create packs that are able to run in a diverse set of conditions.
Correct.
What that means is we will design packs which can go from minus 20 degrees. So it can work in say areas like Ladakh where the temperatures are very north of below zeros, to say Chennai or Rajasthan as we speak where the temperatures are as high as 50 degrees sometimes.
45, 50.
50 degrees, right? So we try to design that using thermal stability, and then BMS have an important role here. So BMS, so why the ambient temperature is increasing now? The cell's performance in itself is they try to drop. So their intent is to save their own life.
Correct.
So what they do rather is they drop on the performance when the temperature increases, and that's why you see when the temperature increases, most of the motor or the powertrains for the electric vehicle companies cut off.
Correct.
That cut off because of the safety, to prevent the pack from going to say thermal runaway or other conditions. What we do is we try to create by our own unique proprietary design a thermal setting which let the cell perform on its peak level while not taking the ambient temperature inside the battery pack more than what is desired.
Correct.
So that's how we solve it. So if the temperature is in negative, so that will do passive heating in order to protect the temperature and give it to a suitable range.
Right.
Similarly, if the temperature have risen above 40 or 45, 50 degrees, what we'll do is try to cool them down using our proprietary techniques which dissipates heat with a very thermal conductive material.
Correct.
So we try to solve this using technology because like the petrol bikes, they are perceived as a single point of mobility solution which can run anywhere.
Correct.
In electric vehicles right now, because of the technologies we are using, it is a limitation, and people do comment on other different type of technologies that can be. Lithium ion right now is the only commercial viable technology electric vehicle industry can use, right?
Correct.
And we need to make it safe, and that's our responsibility as all of the community. So what we try to do is, by using technology, we try to solve these problems, and we try to accelerate the adoption of electric mobility so that people have trust and confidence on the products, and they know that will not catch fire or that will perform on its peak when I need them.
Correct. So yeah, and also guys, for a lot of you who are watching, you might have a lot of background noise as well. So don't mind that because machines are running in full tilt. So ignore that part.
Yeah, so it's a very loud room because our machines run on a lot of electricity and a lot of noise. That's what we do. So our engineers run on a lot of pizza and coffee, and our machines run on a lot of electricity and noise. That's how we try to call it.
Perfect. Yeah, so we understood more about cells and how the testing happens. Now, how do we put together cells in a battery pack in a safer manner? Because there are a lot of things that happens there as well. So let's see a battery pack, if you can show us a battery pack.
Sure. So I think I will have one open for you. So this is an example for a battery pack. So what we do is we use cylindrical cells, and we arrange them in series and parallels to the desired voltages and the desired capacity we want. And in order to do that, we use different materials for thermal insulation, for mechanical insulation, so that it is prone to shock, vibration, noise. So NVH is one of. So what is happening is before this, there were people making a lot of battery packs, but that one thing they fail to understand is the battery pack needs to be mounted on a vehicle.
Correct.
Which is prone to a lot of disturbances from the environment, be it the noise, vibration, jerks from the road, everything, right? And that battery pack needs to be structurally and mechanically strengthened so that those does not translate to say breakage in wire inside the pack or something in cell so that it can get short circuited. Right now, most of the fires you see are because of the poor battery pack design. They're not because of the cells. Cells might work, but because of the design, they are actually getting short circuited inside and causing EV fires.
So here you can see you have multiple cells,
Yeah.
quite a lot of cells
Yeah.
which are mounted in
So
parallel in
these are for R&D purposes. So we do a different lot for production. We try to fiddle around with these packs for the R&D purposes and test what can go wrong.
Okay.
So, and we use all tier 1, tier 2, tier 3 cells just to make sure if what is commercially viable to all of the customers and what is not. So this you see is a tier 1 cell company, also used by Tesla. I cannot name the manufacturer, but yeah. So we use spot welding as of now. We are already also been testing wire bonding and other different techniques to make sure that it has single cell fusing. So we test them, we try to close or on one depending on the pack configuration and again the application, you know. So in electric vehicle industry, what the misconception is key, all of the people try to standardize things. It's not applicable here because depending on the application inside the two-wheeler itself, a low-speed scooter might not need wire bonding, or probably a high-speed scooter or high discharge rate application needs to have wire bonding to make sure the pack is safe.
I was about to ask that question next, because in the current market you have a lot of performance scooters,
Right.
Not something that you have 45, 60 kmph scooters.
Right,
now
right.
it's in excess of 100 now,
Right.
and to have that amount of discharge or current flow, you need to have a solid battery pack.
Correct.
Because that will put a lot of stress on the battery pack.
Correct.
So what are manufacturers doing to withstand that in the longer run? Because
Right.
the faster is discharging, charging, discharging, degradation also happens, right? So quality of cells matters a lot.
Definitely.
And let's say I also have one question here. Let's say we have multiple cells here.
Right.
So let's say one of them have a
Right.
thermal runaway or
Right,
a
right.
damage because of a poor cell quality.
Right.
So what happens there?
Right. So I'll give you a sneak peek around what we are doing right now. So what we are using a unique technology which can prevent any, if say for any reason a single cell is trying to go into thermal runaway or probably is limited by its partners. So a single cell can cause a battery fire, and that's what we try to prevent. So first we try to prevent that cell from going into thermal runaway, but if it goes, it gets opened, circuited from the rest of the pack, so that it is the overcharge short circuit protection is maintained. So what I mean by that is, if a single cell is trying to get into thermal runaway, it will be isolated from the other members.
Okay.
In order कि अब वो एक जल के खत्म हो जाता है.
Okay.
So it burns and it diminishes.
Because the problem we are seeing is once it starts now,
Yeah.
you can't stop
Yeah,
it.
yeah.
It's a continuous chain.
Correct. So it happens because usually when the battery pack design is not good, and because of any mechanical jerk, it gets punctured, and one cell is going into thermal runaway, it short circuits the other cells.
Okay.
And when other cells are in short circuit, so a series and chain of reaction for thermal runaway begins into the pack, and one after the other, it will just blow.
And is it an advantage for you guys just because you guys are staying in Rajasthan? You have an ideal condition to test in super hot conditions so that it can run anywhere in India. If it runs in Rajasthan, it's good for most of our Indian conditions.
So you can say that, but we are present in 14 states, pan-India, and we have the advantage that we have dealers and we have feedback loops around India. So Rajasthan is one advantage because we have the extreme conditions, and while we are testing, we know what can go wrong, because if anything goes wrong here, if everything is safe here, it will be safe everywhere else,
yeah,
right?
yeah.
So that is how we are testing in the battery packs, but it is also very advantageous for other seasons as well, because Rajasthan gives you a very diverse set of conditions. In the winters, it's very chilly right now. It's very chilly when it's at the night. So we also test the packs and how they perform at the night, like 0 degrees, 5 degrees, 6 degrees. So all that happens. But we have tested the packs across India. I'll tell you more about it when we discuss about the OXO.
I don't know how these batteries are withstanding, but we are not able to withstand this heat at all, because you can see us, we are properly cooked, and in the night you can't even go out because it's super cold.
Right.
I mean, it's compared to Bangalore, no? If you are someone from Bangalore, this is
very hot right
Yeah,
now. So
yeah,
it's peak of the temperature right now. I think it's gonna go above 45 degrees for some days or weeks, and then it goes down because the monsoon will come. I'll show you how we also test the batteries here. So once we are done with the cells, and once we take that into pack design, structural, mechanical, thermals, and electrical, we make a pack out of it, and then we do it in both environment. We have environmental chambers which test the pack in different thermal settings. Also, we do electrical testings which give us a lot of data. So if you come closer, I can show you. So the battery is discharging, right? Right now it's charging, but the temperature is still 33 degrees only. So it has to validate that, focusing here, right? So it is to focus that even after, say, charging at a good C rating, because the pack is a lower AH pack. So it's a lower AH pack. So even with a good C rating of charging, it is not moving above 33, 35. The maximum we get is 35 degrees, which is very acceptable because the ambient is even more than that.
Correct.
Right? So once we go and test it into the fields, we have a good stable temperature and thermal profile, what we call it, to actually get into the production level. So we test any or each pack from 9 to 12 months and across India to just validate if it's working or not. And once you have validated, then it goes to production.
So tell us more about this machine, what we are.
Yeah, sure. So this is actually a battery environmental chamber where we put the batteries and we simulate different type of conditions like 45 degrees temperature, 20 degrees temperature, 0 degrees temperature, and then once we do that, we simulate what type of electrical output, or we benchmark against what is normal against what are the thermal temperatures, and we see what are the deficiencies. And we try to solve those deficiencies by increasing the safety in the thermal, increasing the technology so that we can have better thermal performance from the pack.
So you guys keep the battery packs inside this and...
Yeah, it's inside this, and we have different settings. So this is how the data is being collected. Can you show the data? Okay, this one. So you can see, so these two are discharging and this is charging, and we have different C ratings to facilitate the pack. And this is the data where we have the all our BMS, which is into production, are smart BMS. So they monitor data and they can control data as well. Okay. So if something is going wrong, the BMS can instruct a cell to cut off.
Correct.
Similarly, we can have that, is it going wrong or not, we can monitor using the data. And all the packs are smart BMS, so we get continuous relay of data, which we use to analyze, which we use to increase life, and the most important use case is the product development cycle feedback loop.
Yeah. So other thing is, I've seen active cooling and passive cooling systems having in the scooters as well.
Yeah.
So you can't have active cooling all the time.
Right.
And it's not required at some places. Let's say if you're not a performance-oriented scooter.
Right.
So for your scooters, Hop Electric, in the future scooters, is there any plans to have it more safer to get away from this thermal runaways?
So definitely, the active cooling methods and forced cooling methods are being explored. These are very good methods to cool the pack. But right now, till date, and you've been validated in the morning, we have been successfully been delivering good performance and good C ratings with passive cooling.
Correct.
So what we are doing is actually trying to solve this using materials. So what is happening right now, people are trying to liquid cool things or all those things. That is good. But yeah, everyone else. But what we believe that next generation of disruption in thermals and in engineering. So I'll tell you a little bit about how engineering works in general. So in engineering, you can take any rating and it can go above anything. But if you take about a motor, it's a 3 kilowatt motor, you can take it above 12 kilowatt, 15 kilowatt as well. What happens is the boundary condition of any engineering problem are set by the thermals. That if you get beyond this power, it will heat up. And that's why you need to cool it to make it more powerful, right? The same motor can give you more performance when it is in good thermal conditions. And that's how the same thing goes to the battery pack as well. It's an engineering problem. And how do we solve it? So there are two methods of solving this problem. The first method is incremental changes over the current one, like getting it force cool or liquid cool to cool the pack from the external intrinsic materials. The second is changing the materials completely. Correct. And by changing the materials, I mean material science. So if something has a good thermal conductivity, or some, say, for example, I'll show you around for the aluminum shell we have built. It's a new alloy and different type of features, but this is not just aluminum, it's a aluminum alloy mixed with a proprietary metal which allows for a high thermal conductivity. Oh. So anything that goes inside, it very fastly dissipated outside. Okay. So that's how we
good conductor of heat and electricity.
Yeah. So what happens is if pack is heating up, we have good channels that passes heat from the cell to the exterior casing. And this take care of from the exterior casing to the outside using convention and other methods. So what we're trying to do is solve the thermal issues by passive cooling, but innovating on the materials and how we can achieve those same thermal conditions, optimizing the thermal conditions, getting the most performance out of the pack.
And also there are conditions like where you have to ride in the water, and how do you waterproof it, because that's very important as well. Like your phones will have IP67 rated, but now your scooter should also be IP67 rated. So what are you guys doing?
Sure, I'll show you. So we design our own motors. So by design we work with our manufacturers to get the motors IP68 rated. So it's not 67 but 68. It was full in the morning, so we keep on draining it. So right now you can see the motor is working. So this motor is rotating from last 3 months continuously. We just keep changing the batteries and charge it, but this motor never stops. And this is to validate that even in the water temperature. So we are present in, we are not yet present in Maharashtra, but we will be this year. So Bombay and
good example though.
Yeah, Bombay and then places where the water logging is a problem, right?
Correct.
So they have a lot of insecurities about what if my vehicle is stalled in say somewhere where there's a huge collection of water, and then what will happen to the vehicle, because end of the day they have the thought that it's an electric thing, and electric thing don't combine well with the water, right? So to address those insecurities, we actually release a lot of articles, and we also do a lot of testing on our powertrain and system. So both our battery systems and motor systems are IP67 rated, but it goes beyond that because we have been testing it underwater as well in the swimming pool. So videos of which will be shared soon. But what I can say, the water will not be a problem to the scooters or the battery pack, because we make sure it does not create any type of safety or mechanical problem. So you can see here, like the water is running continuously, and 3 months it has been running. We test it for all the vehicles we do, and we then once validated, we get into production.
So these are some of the products that you have in the R&D which is under testing purposes.
Yeah, so we make them, we break them, and then we also try to test what is working, what is not working. So you know, we will be launching electric motorcycles very soon. So this is the updated version of that. I cannot talk much about this, but yeah, we also is in the works right now. So
yeah.
you will know about it very soon.
Yes.
So and then we test about the controller. So one more advantage that we have is that all the systems are connected and smart. So our battery BMS system is very smart, which is able to read and write data. Our motor controller system is very smart, which is able to read and write data. So to say, for example, a very similar use case, if a father wants his child to lock at a speed, he can use it. He can do it using a phone, and the child, it's known as a parental control. The child can only reach a top speed of 45-50 as desired by the father.
Correct.
Similarly for the women's safety. So keeping the system connected helps you optimize the bike over the time with softwares, and also keeping your siblings and all other people safe. And that's what you want: safety and performance and features out of the bike. And that's what we're trying to give. We are making our bikes hardware capable of smart systems. So in the future, when we have the proper update and data for any specific feature, and for I can give you a short example that most people put TPMS or tire pressure monitoring systems into the bikes to monitor the tire pressure of the vehicle, because it directly correlates with the range. If you have a lower tire pressure, you will get lesser range, because the motor will work more in order to get that type of speeds or range, right? But in our case, we are not using TPMS. We have smart ML algorithms which actually classifies from the speed and torque characteristics of the tire. We know on a normal day when the tire is full, these are the torque speed curves. But there's a slight discrepancy in those torque speed curves, so that tells us something is wrong. So either on the driver's side or on the And with the prediction filters we already have in place, and we are improving over with the data, we'll be able to tell you with 99% accuracy that if the tire is deflated or not. And that is the type of magic we'll be able to do using the smart hardware. So we will not invest in the TPMS hardware, but rather a smart hardware on the controller and the BMS side, so that we can correlate that with the data, and with the data we can tell the user to inflate the tires because the tire is low without a TPMS.
Correct. Yeah, and also there were recent incidents of battery packs, because most of the scooters from Hop or removable, except the next one that's going to come up very soon, the non-removable battery. So if you have a removable battery, the tendency that, let's say you are staying in an apartment, you take your battery and charge it at your home. Is it safe? Because a lot of people are skeptical right now.
So I would say it is not, and there are probably a lot of reasons of this, because right now electric vehicle industry is in the pre-checkout phase. And by pre-checkout phase, I mean a lot of people are developing and deploying things which are not tested and validated enough, and there is no clear winner for the technology and for the process that is being established.
Correct.
So it's a risk, and that risk has been transferring from these dealers slash manufacturers to the consumer, and consumer is taking a risk while charging the battery inside their house.
Okay.
It's a big risk. So what we are coming up with, and we'll talk about it more on the other videos, that controlled environment charging is better suited for the customer rather than getting the battery inside and charging, because you know most of the thermal cases have the probability of occurring while charging. So discharging is not much of a problem, but charging rather is a big problem, and charging your battery inside a house can be a good fire hazard for the home. And I don't suggest charging inside the house.
But we don't have a choice, no?
Yeah, well, right now, of course, well, as I mentioned that the industry is in pre-checkout phase, but I believe very soon, because of the battery swap stations and battery charging stations for the charging points, we'll be able to have a good enough density that will suffice and service the electric vehicles which are running around.
You said the controlled environment. I
Right.
think that's something that's the
Right,
bigger
right.
machine there.
Come, I'll show you something. So it's a sneak peek to our swap station. So I cannot show you much, but just this. So it's a swap station where we have a 12 slot system, and it's controlled by a master. All these are slave boards. We have a rectifier slash a charger at the end of it, and then these swap stations, it also have a cooling unit. The cooling unit takes care of controlling the thermal characteristics inside the box where the battery pack is connected and charging.
Don't get confused. So this is the opposite.
This
back
is the
side of the.
This is the rear side of the pack. I'll
So
show you
if
the front side.
If you see here, this is what's happening behind the scenes.
Correct.
So battery pack, you can insert it this box, whatever you have.
Yeah.
Which I'm planning to make a dedicated video. Hope
Right.
that happens. Fingers crossed. So I'll share the inputs, importance, and how useful the battery infra going to be, because that's something that's going to go big in India
Sure.
very soon. Not a lot of people are realizing that, but it's going to go big in India for sure, is what I believe. What do you think?
Correct. So we've been investing a lot. So we were the first ones in India to launch an electric battery swap network for the electric two-wheeler ecosystem in Jaipur, doing the pilot from past 18 months and being successful in riding those. We have collected a lot of data. Testing and validation has been already done, and this year we'll be scaling like crazy. So watch out for the space, and I can only tell you that this is going to be very big in India. For any category that is less than 10 to 15 kilowatts, it makes sense. But any category above 15 kilowatts, I think charging would be a good option.
Charging.
Fast charging can be a good option, yeah.
Okay. So can you give us any sneak peeks of your next upcoming models or something? Which you guys, sneak peeks maybe?
Sure.
For our audience.
So let me take you to my design room now. So yeah, so we are in our design room now, and I can't show you much about the design space, but and of course it's in works. But I can give you a little corner for the sneak peek. That's what we are working on and what we will be delivering in next 1 to 3 years. So let me call my lead design, and then probably we can talk more about that. Taram?
So here at Hop Electric, we are focusing more on mobility. So mobility, not just making automobiles, we focus on energy and automotives both. So here in India today, you can see all the vehicles what are coming up in the market are all consistent and designs are very diluted. So we as Indians are very much connected to our emotional values, very much connected to our belongings. Not just that, culturally also and emotionally also. So somewhere our design philosophy is going to follow that, making some designs that are literally inspired from cultures and inspirations from nature, probably say human existence, rocks, anything coming up from nature, say religions, various natural existence. And what I want to talk more about today is our design process, what happens. So first we'll go with our ideations and all the conceptualizations. One is going to be a Eureka sketch. Then we'll come up with the digital sketching. Then comes this prototyping. You can see prototyping is that process wherein you literally build up 3D surfaces and models. Yeah. So yeah, actually we are literally shifting our studio, so there is not enough displayed. Yeah, and then comes testing processes, and something what I want to show right now is, so this what you see is something from energy, not really products or automotive. This is a charger, universal charger, that's going to be mounted on the walls, and so anybody can literally come and charge. So yeah.
That's about it, I guess. Yeah. So design, with respect to design, we are actually following a very dynamic route, which allows us to build products. So at the very core, we are a technology company, which is at the intersection between energy and mobility. Correct. And we are trying to solve problems, not create products. So while solving problems, we need to create products, and that's how we focus on the design language.
I have quite a few interesting designs here. I can see a lot of unique things. I want to give you a small sneak peek, maybe a second or something, about the next one, which is going to launch about in a month or two. So this is what it's here. I know you have not seen, but we're going to have the launch very, very soon. Yeah. So thank you so much, brother, for helping us and explaining us everything. And also, thank you so much, brother.
I want to add another one thing. So electric segment today, I would say, is a very new thing. It's like a newborn baby. I think it's time to go crazy with things. Why calling it a two-wheeler or a scooter? It's time to get literally something new, what people have not seen, something unexplored or unexperimented. Yeah, that's it.
So thank you so much, guys, and I hope you guys like the video as well. So what's going to come next is more about the charging infra, and I am super excited for it, because whatever we have there, it's super exciting. Nothing like what we have in the market. So I'm going to show that, and before we do that, subscribe to the channel and stay connected, and drop your comments. What do you think about the thermal runaways that's happening in the market and all the incidents that happen? Can you relate to that points? Let me know in the comment section. Until next time, ride safe, wear your helmets, go electric. Bye-bye.
This is our answer to every consumer, every ICE user to make a switch to electric mobility. You get a card, you just click here, which is swiping through the IC card. You put your card here. The balance gets deducted into the system. This opens up.